Okay, on example 3, I call these the two's clues problems. There's a aerial shot from Bolivia. I'm sure you recognize that. Anyway, the two's clues problems. On your free response question, which will be on your test when? Next Wednesday. It'll be something like one of these two's clues problems. And I call them two's clues problems because it kind of sounds like Blue's Clues, right? Did you ever used to watch that, or was that? Yeah. Periwinkle was Blue? Was a girl or a boy? I didn't know either, but I think girl. I think Periwinkle was a cat. I know that, right? That was a pink dog. What was that one called? I thought that was Periwinkle was a cat. I thought that was kind of a purple cat, and the other one was kind of like, I don't know. And then there was Salt and Pepper, and Salt and Pepper had a baby, Paprika. Yeah. Anyway, and then Steve went off to college, quote unquote college, to take care of his drug problem. Anyway, I call these two's clues because much like the dog, we have to solve a riddle, and we have 2 clues that are given to us to help us solve the riddle. So here we go. If sine of theta is equal to 5/6. Now let's just process what that means. We have a trig function given to us, right? And what's the independent variable? Bless you. Theta. We don't know what theta is, but we do know that the sine ratio for that angle theta that we don't know is 5/6, yeah? Which means we have 2 of the 3 sides essentially given to us. Sine is what in terms of x, y, and r? y/r. So we have 2 of the 3 sides. Now, based upon the sine ratio being a positive number, yes, positive 5/6, we know that theta could live in which 2 quadrants? 1 or 2, right? Because the sine ratio is a positive ratio, we know the theta has to terminate in either quadrant 1 or 2, where sine y is positive. But which quadrant is it? Is it 1 or is it 2? Is it 2 or is it 1? We need another piece of information, do we not? Yeah, we do. So here's the next piece of information. It tells us that theta is between 90 degrees and 180 degrees. That kind of puts us in the quadrant what? Quadrant 2. Yes, I would love it if he could come in. And someday I'm going to remember that I sent someone into the hall, and I'll invite them back in. Yes, good. Good call there. Thank you. All right, so now that we know, come on in. Come on in. I didn't forget about you. I was just giving you plenty of time to finish. Bonus time to finish. Are you done? Okay, good. I forgot about you. I'm sorry. Anyway, hey, for what it's worth, 18 years of teaching, I've never once, ever remembered that I put anybody outside. Okay, some people have been out there like all through the weekend just because I forgot to bring them back in. All right, so anyway, once we know now that theta terminates in quadrant what? 2, it says to find the simplified exact value of the other 5 trig functions. So we'll start with that. Now here's what we're going to do. We're going to go ahead and draw a picture. There's my y-axis, there's my x-axis. I know that my angle terminates somewhere in quadrant 2 between 90 and 180. So I'm going to draw just some generic terminal ray. I typically draw them on the 45, even though it's not necessarily going to be a 45-degree reference angle, just so I have more room to draw. And if I drop a perp straight down, I create that little thing called a what triangle? Well, it is a right triangle, but it's also the triangle to which we are referring. So it's your reference triangle. Very good. That's your reference triangle. And the reference angle, remember, is this one here. So the reference angle is not theta. Now what can I do? I'm trying to figure out the other 6 trig functions. How am I going to do that? I need to know all 3 side lengths for that triangle. So I come back up to the ratio that's given, and remember it's the sine ratio, and sine is y/r. Now the side lengths may not be 5 and 6, but remember, whatever the scale factor is, it divides out. So if I'm really just after the trig ratios, I don't need the actual side lengths. The actual side lengths could be 10 and 12, right? Or 15 and 18. I can multiply the numerator and denominator by anything. But the scale factor will always divide out. So what I'm going to do then is label my y as 5. And of course, r is the hypotenuse, and it's always positive because it's a radius. Our radius is always positive. Now, once I know 2 of the 3 sides of that right triangle, I need the third side so I can list all 6 trig ratios. How are we going to find the missing third side in a right triangle? Pythagorean theorem, okay? So the P theorem is what's typically going to be used. And here's what it says. It says x squared plus y squared equals r squared. That's what it is in general for the unit circle, where r is, of course, what? The hypotenuse. It's the radius of rotation. So let's plug in what we know. We're trying to find x. So we got x squared plus 5 squared equals 6 squared. So x squared equals 36 minus 25. That means x squared equals 11. And now when I take the square roots, remember when you take the square root, you need to at least consider plus or minus. So we have either positive square root of 11 or negative square root of 11. Remember, x can be positive or negative, y can be positive or negative. R, the radius, is the only one that has to be whatative? Positive. Good. Now, based upon where we have drawn our reference triangle and predetermining the quadrant in which theta actually lives, which x value do we actually want? The negative one. Good. We are on the coordinate plane. All right, so always consider whether it's supposed to be positive or negative. Now, does the square root of 11 simplify? I don't think it's a perfect square. Does it have a factor that is? No, so we'll just leave it as the square root of 11. And now that we have all 3 sides of this unknown mysterious angle theta, we can list all 6 trig ratios, right? We already have one of them. Let's go ahead and just list them all so that we have a nice complete set. So I'm just going to go ahead and say sine of theta, cosine of theta, and tangent of theta. I'll list them in SOHCAHTOA fashion. All right, so here we go. I'm going to go ahead and write the definitions down. You don't have to do this, but it does help you memorize it. That's y over r, that's x over r, that's y over x. Okay, so now we just go to our triangle and pull the values off. Y over r is going to be what? 5 over 6. Now, that was, I remember, the one that was given, so if we just verify it, we get the same answer. That's pretty good. Now, cosine is x over r. That's negative square root of 11 over 6. And there you go. In general, we're not going to want radicals in our denominator, but radicals in the numerator are fine. Tangent is y over x, so that's going to be what? Yeah, 5 over negative square root of 11. Now, that's not one that we want to leave. We want to get rid of the radicals from the denominator. So when I rationalize, and see if you can do this in your head, I get what?
5 square root of 11 over negative 11?
Yeah. 5 square root of 11 over negative 11. You multiply by square root of 11 or square root of 11. Now, the negative, it doesn't matter if it's in the top or the bottom. I like to put it in the top. It doesn't really matter. The ratio itself is negative. So either the numerator is negative or the denominator is negative. All right, so there's those 3. What I'm going to do now is list the reciprocals, which are kind of the new ones to you, and I'll go ahead and list them side by side. The reciprocal of sine is? Cosecant. Good one. I like your sense of humor. The reciprocal of cosine? Secant. There you go. Remember, the cos don't goes. And the reciprocal of tangent is? Cotangent. Now, rather than just flipping the ratios that we got here, which doesn't really reinforce the definitions, we're just going to actually pull these ratios off the triangle again and then compare and make sure they are reciprocals. It's another way to check. So cosecant is what in terms of x, y, and r? R over y. Good. Secant is r over x, and cotangent is x over y. Good. So let's pull them off of our triangular triangle. R over y is 6/5. That should be the reciprocal of 5/6, is it? Yes, good. So we're checking. Secant is r over x. That's going to be 6 over negative square root of 11. Now, is that the reciprocal of negative square root of 11 over 6? It is indeed. But we don't want to leave our answer like that. We need to rationalize it, so it becomes what? Yeah, the square root of 11 goes in the top of the 6, and the bottom becomes an 11. Negative 6 square root of 11, 11s, essentially. And then finally, cotangent is x over y. That's negative square root of 11 over 5. Negative square root of 11 over 5. And if you compare it, that is the reciprocal of the unrationalized tangent ratio that we got. So there you go. There are all 6 of the trig functions for that mysterious unknown angle theta. We have them. And they're all simplified, which means nothing divides out. And all the radicals are simplified as much as possible. The denominators are rationalized. There's no radicals in the denominator. That's what simplified means. And of course, they are exact. We haven't picked up a calculator. All right, so what can we do next? Well, we've been talking about this mysterious unknown angle theta. We have all the trig ratios for that angle theta. I'm kind of curious at this point what theta is. It's not good enough for me just to know that it's between 90 and 180. I want to know what it actually is. Don't you? Yeah, we're human. We're born with that natural curiosity. If I tell you don't find the angle, that may be the best way to get you to actually find it, right? Because you want to do what you're not supposed to, maybe. No, let's just find it together. How are we going to find theta? Any ideas how we can find theta in degrees? Guess and check? Calculator, right? Does calculator have like a Siri command? Like, Siri, what's theta? Calculator, what's theta? Pretend I have a calculator. Yeah, it's the same result, right? It doesn't work. What do you mean? How can we use the calculator? What? Sine, cosine, something? Yeah, let's go to the calculator. If you have a calculator, feel free to use it. If not, you could just kind of follow along up here. I'm going to demonstrate what we're doing. We're going to work in degrees. So I'm going to go to my mode and make sure that I am in degree mode, not radian mode. Now I'm in degree mode. Okay. If you notice, your calculator only has sine, cosine, and tangent buttons. It does not have the secant, cosecant, and cotangent buttons. And you know why? You don't need them because they're reciprocals of each other. All I need to do to find theta is pick one of these 6 equations that I created and solve it for theta. These are all conditional equations. Now, which one of those 6 would you be more likely to choose? Would you choose one of the 3 equations you created on the right side, on the right column? Probably not. I would probably stay away from cosecant, secant, and cotangent just because why? There's no button on the calculator for them. So, okay, they're viable and they're still good, but I'm going to probably choose either sine, cosine, or tangent just because it's easier, because my calculator's pre-programmed. Now, of the sine, cosine, and tangent, which one of those would you be more likely to use? The sine, for 2 reasons. Number 1, there's no radical in it, right? It's a simpler number. And number 2, probably the best reason, it's positive. It is positive, and we like to stay positive, right? Who wants to be negative? Nobody wants to be negative. We want to stay positive. So that's a bonus 3rd reason. It was given to us. That's probably the most important reason. Not that we made a mistake, but it is possible that these values that we created, there's a careless mistake in there somewhere. So if you use the value that was given, you're more likely to get the right answer, okay? So I'm going to choose the ratio that's given. So I'm just going to rewrite it. Sine of my unknown angle theta is equal to 5/6. Now, the only thing Jared missed when he was outside was our discussion about where theta could possibly live based upon the sine ratio alone being a positive ratio. Sine, the theta could live where? Where is sine positive? 1 and 2. Yeah, 1 and 2. And notice when we solved for x was positive or negative, and so it actually knew that it could have been in quadrant 1 or 2. Now, we know our angle's in quadrant 2, right? Because that second clue. How do we solve for theta? Do we divide both sides by sin? The s's divide out, the i's divide out, the n's divide out, right? Is that how it works? Yeah. No. Sine inverse. Very good. An inverse function undoes the work of a function, right? So guess how you undo sine? It's called the inverse sine. And here's what it looks like. That's called inverse sine. You'll see later that it has a different name, arc sine. But right now, we're going to take the inverse sine of both sides. And it has to go on the left side. It's an operation, not a multiplier. We're taking the inverse sine of both sides. It's like taking the square root of both sides, or squaring both sides. Now, guess what happens on the left? If you start with theta and you sine it, and then you inverse sine it, guess what you're left with? Theta, right? If you're standing at one spot and you take 2 steps to the left and then 2 steps to the right, you're back where you started at theta. And now we're left with this, inverse sine of 5/6. That's something that we can type into our calculator. Because your calculator, has, as with most keys, the inverse function on the same key as the second command. Just like we have log base 10 and 10 to the x. We have the natural log and e to the x. We have x squared and the square root. They're on the same key. On the same key of sine, if you look above there, it says sine to the negative first. We read that as what? Inverse sine. Now, you're going to want to know in advance if you want your angle in degrees or radians. I'm telling you we want our angle in degrees, because it said it was between 90 degrees and 180. So if you check your mode, which you should always do first, now all we have to do is hit second sine of 5 divided by 6 and hit enter. All right, and notice it gives us the answer. Theta is 56 point, I lost it, let me see, 442. If we go to 3 decimals truncated. And we box it up and walk away because that's the right answer, yeah? No? Uh-oh. Yeah. Makes sense of your answer. We said our angle had to live in quadrant 2. The angle that the calculator gave us was in quadrant what? 1. All right. Well, let's try it again. Maybe this time we'll be more specific. If you just want to hit second enter, that'll recall the previous line. This time before we hit enter, let's try this. Calculator, give me the answer in quadrant 2. Then hit enter. And it still gave us the same one. Let's try it again. Recall it. This time a little more forceful. Calculator? I said calculator, quadrant 2. Now I paid good money for you, calculator. You better do what I want you to do. Calculator, quadrant 2, please. I said please. Guess what? Doesn't matter how nice you are, how mean you are, the calculator is never going to give you an angle in quadrant 2 when you take the inverse sine of a ratio, because it's not programmed that way. Because the people who programmed it didn't want to steal all your fun. So thank you, calculator, for giving me yet another clue that will help me find the answer. All right, so let's see what the calculator gave us. Right? The calculator gave us a positive acute angle, and that's going to live in quadrant what? Quadrant what? 1. Okay, so let's see. What? Never mind. Okay, we can mind. I don't know if it's coterminal, because a ray that terminates in quadrant 1 is not going to be the same ray as something that terminates in quadrant 2. But here's what the calculator basically told me. It said, hey, if you take the sine of 56.4, right there, if you take the sine of 56.442 ... degrees, you're going to get a sine ratio of 5/6. The calculator has no idea which quadrant we want. It's just giving us an angle whose sine is 5/6. Now we have to interpret the calculator's answer and use it to find our answer. So yes, knowing that this is 56.442, the triangle that I want, as we saw with the unit circle, is going to have the same angle right there, and that's still 5 and that's still 6. And the only difference is the one we want had a different x value. But the calculator had no idea what the x value was. It's programmed to give you one answer and one answer only. So now we can use the calculator's answer to find ours. And as you already saw, the angle 56.442 is not our theta, but it ends up being the what of our angle? the reference angle. Very good. So I'm going to come back over here and add REF to that. The calculator gave us an angle whose sine is 5/6, but it's not the one we want. So we can find the reference angle, and now we can use the reference angle to find our angle. So let's do that. If I know that I'm stopping 56 degrees short of the negative x-axis, how would I find theta? 180 minus. Good. So drawing the pictures is going to be very, very helpful here. So my theta ends up being 180 degrees minus the reference angle. And now on my calculator, which has the reference angle stored in its full decimal glory, I'm just going to do 180 minus the answer. I'm not going to type in my 3 decimal truncated answer, because if you're ever off in the third decimal, you're wrong. So it's 123.557. 123.557. So you can round or truncate to 3 decimals. There you go. Now, here's a good way to check ourselves. I'm going to store that answer as X. If you hit stow right above the on button, it'll say answer, convert it to X. You hit enter, there it is. Let's verify, okay? Let's see what the sine of that angle is. Because that's not the one the calculator gave me, right? We found that one on our own. It's 0.8333333333333, which if you hit math, enter, enter, gives you 5/6. Bless you. What does that mean? That means the calculator is as smart as we are. Yeah, we got it right. Now, let's do something else here. Let's check another one. Now that I have my angle, it says that we found the cosine to be negative square root of 11 over 6. Let's see if the calculator knows that, okay? Let's take the cosine of our angle in its full decimal glory, and we get negative 0.552. Well, let's see what negative square root of 11 divided by 6 is. Oh, not like that though, right? That would be a horrible way to do it incorrectly. Divided by 6. Make sure you're outside the radical. Should we get the same answer? I hope so. There you go. And you could verify all the others. Let's verify one of the new guys. All right? Let's verify the cotangent. I stored my angle as X. I want my calculator to take the cotangent of the angle that I have stored, and I want to see if I get negative square root of 11/5. Let's do the easy one first. Let's see what negative square root of 11 divided by 5 is first. Okay, I get that. Now let's take the cotangent of my stored angle. How do I take the cotangent on my calculator? There's no cotangent button. What? Good guess. If I hit second tangent, notice we've already done that with the sine, right? We hit second sine. And I said if we hit second sine, that's not the reciprocal of sine, that's the inverse of sine. So this is the inverse tangent. That's the function that undoes taking the tangent of something. That's not how we find the cotangent, because the cotangent is the what of tangent? The reciprocal, yes. So as Jared said, we don't take inverse tangent, we just do 1 divided by tangent of our stored angle. It's the reciprocal. That's how you get the other 3 trig functions on your calculator. 1 over tangent is cotangent, 1 over sine is cosecant, 1 over cosine is secant. That should give me the same answer. There you go. All right, let's do one other thing with this problem. Now that we know our ratios are right, I chose to use 5/6, the equation sine of theta equals 5/6 to get my angle theta. The calculator didn't give me the answer I wanted, but it gave me enough information to find the one I wanted. What if we had chosen to use a different trig function to find the angle theta? Should we get the same answer? We should, right? Is the calculator going to give us the same answer? I don't know. But it might give us enough information to find it. So let's use the cosine and see if we get the same thing. So cosine of theta was negative square root of 11 over 6. How would I then solve for theta? How would I get rid of the cosine? Take the inverse cosine of both sides. Inverse cosine of theta, inverse cosine of negative square root of 11 over 6. And again, that's a function, an operation, so it has to go in front of on each side. Now, of course, on the left side, what do we get? Theta. So this right here is what I would need to see on a quiz or a test. You wouldn't have to show the line above, but I would need to see that step. Anytime you're typing something into a calculator, I need to see exactly on your iPad/paper what it is you're typing in. Now we'll go to the calculator. We're still in degree mode. No one came up here and switched it, as far as I know. So let's just type in the second cosine of negative square root of 11, get out of the radical, and divided by 6. And I have no idea what the calculator is going to do. When I did the inverse sine, it didn't give me the answer I wanted. I have no idea what this is going to do. But it will give me an angle whose cosine is the same. Oh, cool. What did the calculator do? It gave us the actual answer that we wanted. So does that mean we should always use cosine? Is cosine always going to give us the answer we want? No, not necessarily. You'll figure out why the calculator is giving you a particular answer later on. But right now, know this, that it doesn't matter which trig function you use, your calculator will always give you either the right answer or an answer that will help you find the one you want.
Well, did that one give us the right one? Using the x value
It was using the x value, yeah. Now, notice I told the calculator to give me an angle whose cosine is a negative number. In which two quadrants is cosine negative? Cosine is negative in 2 and 3. The calculator has no idea if I just tell it, give me an angle that has a negative cosine, if I want an angle in quadrant 2 or an angle in quadrant 3. So what it does is it gives us a 1 always in quadrant 2 because quadrant 3 is a little bit further away. Just like when I tell it to give me an angle whose sign is a positive number, quadrants 1 and quadrants 2 are the possibilities. It gives me 1 in quadrant 1 because it's closer than quadrant 2. So that's how your calculator is programmed. Now, how would you know if this is the answer we want? It's between 90 and 180. So if we know that this is our angle theta, how could we then use that to find our reference angle? Yeah, perfect. It's 180 now minus that. And if you type that in, you're going to get the reference angle. So when you did the inverse sine, you got the reference angle first, and you were able to find the angle you wanted. When you did the inverse cosine, you ended up getting the angle first, which you could then use to find the reference angle. And the reason it's doing that is, remember, there are 3 triangles, in addition to the one we drew, that have the same magnitude on your x and y's. The only thing that differs is the sign. Okay, so the reference angle on all 4 of those triangles is going to end up being the same. And your calculator will always give you an answer that has the same reference angle as the one you want every single time. Let me repeat that. Your calculator will always give you an angle that has the same reference angle as the one you want. So if you can find the reference angle of the calculator's answer, if it's not the one you want, you could then use that reference angle and then your knowledge of where you're terminating to work off the x-axis to find the angle you want. Kind of fun, huh? It's a Two's Clues game. It's like a whole episode. Yeah. You'll always have enough information to determine which quadrant it needs to be in. Yes. Very good. Very good. If we knew that we had to live in quadrant 3 and the reference angle is 56.442, all I needed to do to get to quadrant 3 is go 56.442 past 180. So the angle would be 180 plus 56.442. Yeah. Now, what would happen if we used the inverse tangent? Just kind of using the last button here. Let's see what that would give us. That would be if tangent of theta is equal to negative 5 square root of 11 elevenths. Sorry. all you would need to show me on your quiz or test is that theta would equal then the inverse tangent of negative 5 squared of 11/11. Now this would be probably the last and third option that you would have simply because that button is on your calculator. Let's see. Second tangent of negative 5 square root of 11, get out of the radical, divide it by 11. Now before I hit enter, we got a couple of minutes left. I'm asking tangent to give me an angle. I'm asking the calculator, I'm sorry, to give me an angle whose tangent is negative. In which two quadrants is tangent negative? Tangent's y over x, yes? So y and x can both be positive, both be negative. So you're going to have a negative tangent ratio when x and y are opposite signs, yes? They're opposite signs when x is positive, negative, and y is positive, and when x is positive and y is negative. So in quadrants 2 and 4. Which one do you think the calculator is going to give me? An angle in quadrant 2 or 4? 2? You think 2? You think 2? I don't know. Let's see. I'm going to guess quadrant 4. What the? It gave me negative 56.442. Is that the reference angle? Right. It can't be the reference angle because the reference angle is positive. This is an actual angle. It's negative, so you rotate what? Clockwise, which puts you in quadrant 4. But remember, you can use this now to find the reference angle. Just break off the negative. And now you have the same reference angle. If you know you need to be in quadrant 2, 180 minus the positive 56, and you've got it. There you go. That one example, lots of fun. That's going to be your free response. Your mathematical sleuths, mathematical detectives. All right. Tomorrow we're going to move a little bit more rapidly, so when you come in, grab a calculator, and we'll get to example 4, 5, and 6. They get more interesting than that. I'm going to dump this into the shared folder, so if you're not here today, mentally, maybe rewatch it. Don't forget your other quiz tomorrow, 10 and 10, all 6 trig functions.